So in this lecture, I'm going to be talking about how you can use repeat for every item and show steps that's part of text to code to go through a list and repeatedly perform a given operation. So let's give an example of an application. Suppose you wanted to add the numbers, or add the positive integers, I should say, from 1 to n. Right? So if you gave an input of 5 to this function, sum of positive integers from 1 to 5, you would want to get 1 plus 2 plus 3 plus 4 plus 5, or 15 from this function as an output. Well, if you notice what we did here, we said that we wanted to go and repeat for every item and show steps on the array range 1 comma n plus 1. So if you remember the way range works, it generates a list of consecutive integers starting with the initial number you give it and ending one before the integer that you give it for the second input, right? So this would go from 1 to 1 less than n plus 1, or 1 to n, right? So if n here were 5, right, then it would just go, you'd have range 1, 6, 5 plus 1 is 6, and that would just do the list of integers 1 through 5, 1, 2, 3, 4, 5, right? And so what do we want to do with all of these integers? We want to add them all up, right? So you'll notice here we have the ACC plus num, right? We're going to add the accumulator to the number, which I'll talk about in a little bit here. And then we're going to start with an accumulator of 0. Right? So the way this works is that whatever I'll show this on the next slide here, we start with the accumulator that you use starting with ACC of, right? So we're saying we're starting with 0, and the starting item that we're going to have here is the starting item from the list, right? So this again was the list 1, 2, 3, 4, 5 in the example that n is 5. So what's going to happen here is it's going to put in the 0 for ACC, it's going to put in the 1 for num, and it's going to add those two numbers together. And whatever you get as the result is going to become the new accumulator that gets put in here, and we'll go to the next number in this list, which would be 2. And then again, you get the result, and whatever the result is, that becomes the new accumulator, and the next number 3 gets put in, all the way till you get to the end of the list. So let's look at this table again here. Right, so we had the starting accumulator of 0, item was 1, and each time we were adding the accumulator in the item, right? So here we have 0 plus 1 is 1. This 1 becomes the next accumulator. The next item in the list is 2, so now it's adding 1 and 2 to get 3, right? And then the 3 becomes the next accumulator, adding 3 in the next item in the list of 3 to get 6, right? And then you get 6, add 4, which is the next item, to get 10, and finally take the accumulator of 10, add the last number in the list to get 15, and the final accumulator is your output. So to actually think about why we set up the table this way, why we set up the function, how we knew to just do ACC plus num here and not do something like ACC plus num plus 1 or something like that, is we basically have set up the table so that we want the accumulator to represent the sum of all of the items that have come before, right? So for instance, when we're at 6, we want to say that the sum of the integers that came before here, this 4, 1 through 3, is actually 6, right? So we want this accumulator to be the sum of the integers before this number. So this number really represents the one that we're up to, right? So going with this logic here, each time, what are we going to do? We're going to add the accumulator, which is the sum of the numbers from before, to the next item to get the next accumulator, right? So it really just models how you add numbers naturally, right? So if I start giving you numbers and I start saying, okay, 1, all right, so you're thinking 1, right? and then I give you 2 next. So now you're saying, okay, let me add that 2 to the 1 to get 3. And then you're given 3, and you say, okay, now I'm going to add that 3 that you just gave me to the 3 I have, and now I have 6. And next I give you 4, you're going to say, okay, I'm going to take that 4 you just gave me and add it to the 6 and get 10, right? So the point is, you just keep storing the sum of the numbers that I've given you so far, and you're just going to add it with the current number, and then when I stop giving you numbers, you know that you have the final sum, right? So this gives you an idea of why each time we're just saying take the accumulator and add the number. Now, something that you might also not be sure of here is why we start with 0. Well, if we're constantly adding the accumulator to the number, and we have to go through the same pattern of always adding the accumulator to the number, regardless of what row we're at, we don't really have a choice, then it makes sense we would start with 0, because 0 has the property that if you add it with any number, you will get back that number, right? So when you add 0 with 1, you just get back 1, right? And if I just gave you one number, that would be the number you're thinking of. If I'm saying like, okay, add up all these integers, then I give you 5 as the first number, you're thinking 5 as the accumulator, right? So you would like to start with whatever that first number is. But before I've given you numbers, you would say, well, what should I start with? Well, if you started with something like 2, and then I give you the first number of 5, and you're forced to repeat the same pattern of adding the numbers together, then you're thinking of 2 plus 5 is 7, right? And you would be thinking of 7 instead of that first number of 5 that you want, right? So that's why we started the accumulator at 0. We won't always start the accumulator at 0. It really just depends on the problem. So as an example, if we were multiplying numbers, we would not want to start with 0, because for multiplying, we would be doing times instead of addition, right? So if I started with 0 and then I give you that first number of 5, you're doing 0 times 5 is 0. So now you're thinking of 0 instead of the 5 that you want. So there would be an example when you would start with an accumulator of what? So if you thought 1, that's correct, right? Because 1 times 5 would give you 5, or more generally, 1 times any number would give you that number, right? So once you've set up the table, right? So this is really the main step, right, is actually setting up the table and identifying the pattern. Because once you've set up the table, the code comes naturally, right? So whatever's in your first row, first column, so your starting accumulator, is going to be what you put in that starting with ACC of, right? Whatever your first item is, right, that's going to be the beginning of your range, right? Because that's going to be the first one that goes for this second input to the function, right? And this is the one that goes for the initial first input, right? So this is the initial first input, and this will be the initial second input, right? So then you also say, well, when are you going to stop, right? When you're going to stop determines what you put, and when I say stop, I mean what item are you going to stop with? That determines what you're going to put for the second number to range here. Now here you notice I stop at 5, and remember that range would need to go one more, so we would stop at 6. But the reason I can't put 6 here, right, is because I won't always be adding up the same integers. I'm not always going to be adding up 1 through 5. So in general, if I gave you, for instance, like 10, you would want to do range 1 to 11, right? If I gave you 20, you would want to do range 1 to 21. So the pattern here is just to take the number I give you, that ending number I give you, and add 1 to it, right? So that would give you your ending number to range. And finally, you have the function that you pass to the repeat for every item and show steps. Now to figure out what you're going to do there, you basically just look at the pattern. How do you go from one accumulator and one item in a row to the next accumulator? And you could see over here I have 0 and 1 and I get 1, and 1 and 2 and I get 3, and 3 and 3 and I get 6. So the point is, each time I'm just adding the accumulator and the number together. So whatever the pattern is to get from the accumulator and a number, or the accumulator and the item in the row, to the next accumulator, is what you put in over here for the repeat for every item and show steps. Now let me also point out that we don't have to call this ACC and num, right? You could call this like foo and num, right? The whole point is that the first parameter is going to be just your accumulator, whatever that is, regardless of what variable we call it. And the second one is just going to be that item, right? So initially, the first thing that's going to be this is whatever you put here, and the first thing you put here is going to be what you get from, right here, right? So this would be the 0 and the 1, right? Of course, if I did call this foo, then I would have to make this foo as well. Right, so this is really the general pattern. Let me give you another example here.